Hello world, Christian Truther here again, and I've got another video for you. This is part 8 in my series on the shape of the world. Is it round or is it flat? Can we determine what the objective truth is about that shape? Because the shape is what it is, regardless of what we think about it. Now before I get into the topic today, again, here are my ground rules. Very important to me, but I don't read them aloud, so I expect you to read them. But the top 2 are my promise to you, and the bottom 2 are what I hold you guys accountable to in the comment section. As always, this is unscripted, no green screen or anything like that. I'm not trying to improve my arguments through that sort of technological polish. And I also always recommend watching my first video on this topic, because in that video I discuss why I'm doing this and what my methodology is going to be. I do tackle other topics in plenty of the other videos on this list. Like I said, this is part 8 of my series. This is going to be the second part on a celestial body movement. So we're going to aim arguments from each side of each other and see which one stands. Now originally, I was not intending for this to be a debunk video, but it kind of became that as I encountered some thinking that's not accurate out there. So let's start off, and we're looking at star movement. So we're going to see this is what reality is. And someone was kind enough to do a time lapse with a 360 degree rig. So you're going to see simultaneous both hemispheres movement. They're a little bit north of the equator. You can tell that through how the stars move and what stars are visible and everything like that. But this is going to be what is reality as far as what we see of star movement. So let's take a look here as soon as YouTube loads up. Okay, so I think that gets the point across. Clearly, as I said, they're a little bit to the north of the equator. You can see Polaris here. Star trails, because it is a time-lapse sort of shot. We do see a good portion of the southern hemisphere. Now, a couple words about, like I said, this is reality. This is what's actually happening in the sky. I've heard one person say that modern astronomy claims that the stars move counterclockwise in the northern hemisphere and clockwise in the southern hemisphere, but that would mean that it's rising from the east to the west in the northern and going from the west to the east in the southern. No, it's not. It's all coming from... That's what modern astronomy is claiming, so please don't say that anymore. Modern astronomy is not saying that in the southern hemisphere stars claim to be rising in the west and setting in the east. You just misunderstood what clockwise and counterclockwise were. So let's take a look though at what some other ideas are as far as what is causing the star movement. I have here a very popular video by Eric Dubé, and yeah, let's see what he says. First of all, he says Polaris is the only motionless star in the heavens. No, it's not motionless. Actually, it wobbles. If you take a you're going to need some magnification. You need a long, video time lapse of it, but you will see it wobbles. Also, you're making this claim thinking that Polaris doesn't move, period. But it does. In fact, we used to have a different North Star. Back when the Egyptians were raising pyramids, they described a star called Thuban, and it's in the constellation Draco, as the North Star. Polaris was on the outer ring. So there is some wobble, and it's not immovable. Their relative positions, if Earth was truly a tilting, wobbling, spinning ball, so he's saying basically that the stars stay still in their positions despite the fact that we're moving. And to expound on that, he says, if the Earth is spinning at 1,000 miles per hour as it revolves around the Sun at 66,600 miles per hour, while the Sun shoots through space at 450,000 miles per hour, why haven't the constellations changed in thousands of years? So, again, they have. We had a different North Star. Also, we occasionally lose stars through like supernova events and stuff like that, and then poof, they're gone. We don't see them anymore. But I understand what you're saying. And the basic premise falls short because you're not really taking distance into account here. The distances involved are massive. And the best I can explain it would be is if you were at the dockside of Seattle and you looked over your shoulder to your left and you saw the Seattle Needle, okay, and it's easily recognizable landmark. Now, if you moved quite quickly 20 feet forward and look left again, Seattle Needle basically wouldn't look like it have changed position at all. But yet the shops around you have. And you move forward another 40 feet, same story. And 100 feet, same story. You would have to travel for a very, very, very long time in order to be able to see any perceptible movement of the Seattle Space Needle, and it would be very small. It's because distance relative to you, things close by will change a lot. Things that aren't close by don't change. So that's why the sun changes rapidly. The moon changes rapidly in its position in the heavens. But these stars are so very far away that relative to us, we haven't moved hardly at all. And most of them are caught actually in the same galaxy we are, so they're actually spinning with us. It's not like we're the only things moving. They're moving as well, and so it's kind of, most of the stars that we see that are visible in the sky are in the same part of the galaxy we are in, and they're all moving basically in the same direction at roughly the same speed. So the Earth is rotating, and that's why the stars are wheeling in the sky night after night. We see this. So this is flawed thinking. But moving on, we then begin the perceptual basis argument, which is false. He's basically making the argument that you can't see infinitely far. You've got a visual range, and you can't see infinitely far. You can't see distance really at all. What you see is light striking your eyes, and then your brain is processing that information. So we see light at great distance. An example of this would be lighthouses. You don't see them, but you see the light flashing first. Okay, as the ship is approaching, they would see the light flashing first. The light was striking your eyes. So even though we couldn't resolve the object out there, we could have seen the light. And that's what you see. You see light striking your eyes. And it doesn't matter from what distance it's coming, as long as the light comes to your eyes in sufficient quantity to be registered, you will see it. Okay? So light doesn't just stop working that way. Our eyes don't just stop processing because it's a certain distance away. Well, they don't know that. It's the light gets to our eyes and we see it. Okay, so there's not a perceptual range challenge here. Vanishing point is not an issue. If light is getting to our eyes in sufficient quantities, we will see it. Period. End of story. And then he goes on to say, well, south is on these edges, and this is going to be a real problem. Because remember reality. All right? I'll just back up there real quick. Tight arcs. Shallow arcs. Polar type arcs. Okay, and I'm going to show you a video real quick of the Southern Cross as well. All right, we're going to trace the Southern Cross here. And it's right here. Okay, and it's pointing south for us. That's why they call it the Southern Cross, not just because it's in the Southern Hemisphere. So there's a lot of problems with that. You've got polar movement. You've got the fact that no matter where you were, there were those four guys facing south and facing vastly different areas of the south. But for most of the night, again, grant you not necessarily all the night, but for most of the night, all four of those guys see the same Southern Cross. That shouldn't be possible on a flat disk, with south being all the way around the rim. But whether you're in Chile or Australia or South Africa, you can see the Southern Cross for most of the evening. That's just reality. Now, this guy had what appears to be a fairly ingenious setup, and I took a shot of him from the top first. So he's got the Southern constellations on the top disk and the northern constellations on the bottom. He put the camera right about the equatorial point, similar to what we saw in that shot. And his argument is that this disk is inside a dome. The dome creates a reflection event at nighttime, and what we see are the stars on the southern being reflected down. It's a decent argument, and let's take a look at what it looks like. He zoomed it in so you can see it better. But certainly, as this spins this way, this will spin this way. And it does kind of mimic what we see as far as star patterns, and you would get a polar event. Great job. Oh, by the way, we do have a South Pole star, but its magnitude is so dim that it's very difficult to see without visual aids. Certainly a long exposure shot would be able to see it. There is a star currently occupying the South Pole. I do want to cover that before we get too much further. It does exist, though. But here's what you don't see. The stars that were in the center on both. You would have, absolutely and necessarily, you would have divergence points with this sort of setup. And we don't see that in reality. So again, this is not accurate. It's clever enough little contraption he put together there, but it doesn't match reality. Then someone said, well, you know what? If you put a dome over and the lights were on the outside, it can create polar sorts of events. The problem with this, not only do we not see trails all the time, as this is kind of showing, but more importantly, the poles are at either side of this. But what do we see supposedly on the flat Earth map? You'd see a pole here, and then somehow a polar event occurring simultaneously on all sides of it, and that doesn't work out, not with this. So not even a dome magnifier is answering the question of how we see the reality of how stars move. So the truth is that the world is round, and that's why we see the stars revolve the way they do. And the reason they don't seem to change very quickly or hardly at all as far as their relative positions in constellation to us is because we're all moving at roughly the same speed and roughly the same direction night after night, year after year. But things do change. Things have subtly changed. We've got a new North Star. We expect in a little while longer, it'll be actually a great while longer, we expect another North Star to take that one's place. Supernovas happen and stars disappear. These things happen, and it's not completely unchanging over time. The truth is the world is round, and it will set you free. This is Christian Truther, signing out.